There are so many questions there in the chat stream, and some of you were noticing that our own Professor Ingrid Sheffer from here in Melbourne was answering some of those. So we've rounded her up, convinced her to come back live on Zoom. Ingrid, thank you so much for joining us, because we really are, at the vanguard of some very exciting times in terms of therapies. But I know families are keen to know what of these might directly be relevant to KCNQ2. So let's start with a couple of questions that we're getting. Wondering how many of these treatments are viable for KCNQ2 specifically. Do you have any thoughts on that just to start?
Yeah, I do, absolutely. I thought Oren's talk was fabulous, really cutting edge and describing really complicated concepts. So I think it goes back to where we started this about 3 hours ago, and I talked about loss and gain of function. And with Oren's descriptions, you can see that, in fact, you may need a completely different approach for a loss of function versus a gain of function. And that's already playing out very nicely with ASOs, which he talked about, antisense oligonucleotides, where if there's a gain of function mutation in a mouse model, we'll start there, they show very nicely that the ASO can bring down that gain of function in the mouse. And Steve Petru, who's speaking tomorrow, will, I suspect, talk about that, because he's done that beautifully in SCN2A mice and KCNT1 mice. That's a different potassium channel. On the other hand, Oren also talked about using an ASO to increase function. And I think Dravet is a really good example of that, where you have a loss of function mutation, which we know is the case in most of the children with the early onset developmental and epileptic encephalopathy due to KCNQ2. So if you have a loss of function mutation, the option that you have then is to up the good copy. You've got a good copy and a bad copy of KCNQ2. If you can increase the amount of protein from the good copy, maybe you can compensate for the bad copy not working. And that's where an ASO approach works. And we know that in the Stoke mice that Oren showed, they're looking much better, they're living, they're not dying, no SUDEP. And so we know that can work in Dravet. What we don't know is, can it work in KCNQ2? But I bet you the same principles will work.
Well, and specifically regarding haploinsufficiency, we have some parents who've been told that that's just not going to apply for KCNQ2, or it depends on the variant. It sounds like we're not going to know the answers to all of these questions yet. Is that right, Ingrid?
I think we're not going to know for specific mutations yet, but we do already have an idea of the themes. But for your child, what matters is you need to know what's the story with your child's mutation. And it seems lots of people have different mutations, so each mutation might be slightly different, but there are some recurrent mutations, such as the one that Snezana talked about, where she's done a lot of work characterizing that mutation just beautifully in cells, frog egg cells, and in neurons, and then in these organoids. And she's really getting a complex picture of what that mutation does. Now, it'd be great to do that for every mutation, but that's probably a full-time associate professor like Snezana in her laboratory for a year to see what we saw, maybe 2 years. So that's not absolutely practical, but we will begin to understand that different mutations cause different pictures, and then target new gene therapies for each different picture.
All right, Ingrid, a couple more questions for you. And we should mention as well to everyone who's watching that we'll also reach out to Steve Petru, who he's going to be speaking tomorrow, but it will be recorded, so you won't have a chance to ask him questions. And we'll loop back to our other experts, because we'll also be hearing from Sarah and Al tomorrow, Sarah Weckes and Al George. But we've got Ingrid here. You're an expert, Ingrid, on all of this. I wanted to ask you all about some other developmental issues that go with this. For example, autism spectrum disorder, or gait issues. I mean, are those kinds of problems ones that can be treated with some of these targeted therapies? Is that in our future for KCNQ2?
Absolutely, that's what we want. We want it to cure the whole disease, so not just the seizures. And as I showed, there are all these other aspects, and Anne Berg discussed and Lynette discussed, there are so many different aspects to this disease. So our job is not done until we've cured all of it. Now, is that realistic? I don't know is the answer. I hope it is. I think gene therapy takes us to a completely different level in terms of treatment. Before we were just looking at seizures, trying to get them under control. And we already see evidence that if you can get those seizures under control, we see the children are doing better. That's not documented in terms of how do you compare it if you've got one child and you're following it, but we do see that they're not as delayed in terms of, and they're making good progress. I'm certainly aware of some in Melbourne that have done beautifully with very aggressive therapy. So, but we still don't know what the long-term point of that is. They're good now at 1 or 2 years of age, but will they be good at 20 years of age and 50 years of age? And we don't know the answer to that. So the idea of gene therapy is you're getting at the actual cause, much more focused, targeted approach. And if you get it in early enough, maybe you can actually end up with a normal individual in terms of being typical in their development and being able to function like the rest of us.
Ingrid, how do parents want to know, how are they going to know which specific treatment or therapy is going to be the one that helps their individual child? What thoughts do you have on that with this diverse population?
Well, I think they're not really going to know without getting expert advice. And that expert advice is by, where would I start? I'd start with your neurologist or your pediatrician. I'd start with KCNQ2 Cure, where you can see if it's a known mutation that other people have got. There may be a lot of information about it, such as the one we heard about from Snezana. If your child had that mutation, we'd have a whole lot of information about that specific mutation. So you need to start with experts. If your neurologist doesn't really know, it's not their sort of area, you could ask your geneticist. They should be able to look at this up and tell you. And then I think being informed, being involved in organisations such as KCNQ2 Cure and the international bodies are really important, because that's where you hear about the latest things and you can hear about where to participate. The other key issue, of course, is the natural history studies. So if you...
I want to talk to you about that, Ingrid, because you're working on a natural history study as well. You're based here in Australia. Can you tell me about that natural history study and what you're doing? And then we'll talk about why they're so important.
Okay, can you hear me? My computer's just saying you can hear me.
We can hear you perfectly.
Just telling me it's not working properly. So the first thing is we all want to work together, all the teams around the world. We want to get the best information we can for people with KCNQ2 disorders. And I'm part of a 30-year program since I started working in epilepsy genetics with Sam Berkovic back in the early 90s. And we've studied families, patients for years, for that long period of time, and that effectively has been mapping out their natural history too. But now, as you heard from Anne Berg, natural histories are much more being formed in a much more specific way and being done in a way a lot more rigorously. And we want to see the children every 6 months, and you're going to have neuropsychologists actually assessing the children around the country. Now, we're very lucky, we've just got funded quite significantly for a whole group of us, paediatric neurologists around the country, geneticists, particularly Emma Palmer in Sydney, neuropsychologists, Sunny La and Claire Wakefield, to look at the impact on families, and molecular geneticists, so science, laboratory scientists who work in genes, and bioinformaticians. The team goes on and on. But we've been very fortunate. We've had a number of grants just awarded in the last few months, and it means that we're going to have a really big program around this. And I think that Anne Berg's talk beautifully delineated the challenges. How are you going to tell if a child with a very poor level of functioning is making a gain. And at the moment, we largely rely on parental reports, and I still think they're the best, but we need to get objective means to do that in order to have clear data to show that a drug works. And again, Anne showed that beautifully with the CLN2 story with Batten's disease, and they've had the CLN2 metric that they've used. Now that metric has been good, but it isn't great because it doesn't pick up on subtle changes. And that's where Anne showed just so beautifully how you need to look at the scale of the change you're looking at. If you've got the wrong scale, you're going to miss the changes. So we're very excited about our natural history study. We certainly intend to work with Anne and Anne. There are two Annes in the US who are both wonderful, and put our data together. But it means if you're in the natural history study and the companies find a particular gene therapy for your type of mutation, we'll know about you. We'll be able to say, oh, they want a 1-year-old with this type of mutation, and that's who we'll target. That's exactly what Encoded and Stoke are doing. And so you need to be in it to win it, as we say in Australia.
Yeah, I can't even tell families how important that is. We want you to sign up. We'll provide information from, for Aussies, for those of you who are here, we'll get you information about how you can enroll there with Ingrid Scheffer. And we also, she mentioned 2 Anns in the United States. Tomorrow, everyone, you're going to hear from Ann Paduri at Harvard Boston Children's, a friend of Ingrid Scheffer's, and she's going to tell you about that natural history study. You're definitely going to want to participate. And Brandon Obi, who works with Ann Paduri, is going to tell you how you go about the intake process. And the significance of this, everyone, is that if we have that data, we more richly understand KCNQ2 in all the myriad ways in which it's working in our population for your children, no matter whether they've just been born or if they're in their 30s, as one of the moms on the group chat was just saying. We'll have an understanding, and as Ingrid just pointed out, be able to let you know when there are therapies that are available that might be relevant to your particular child. So it is so important, and Oren mentioned it at the end of his talk. So I just want to do a big shout out now to Ingrid Scheffer for staying, for answering questions in the group chat, for answering questions related to what Oren was talking about. I think we can tell what a wonderful community it is, and we're lucky to have all of you as our friends here at KCNQ2 Cure. Thank you, Ingrid.
Thanks, Sarah.